In this video, we're going to be going through tree diagrams and also lattice diagrams. Now, both are a part of this course curriculum. However, tree diagrams are used more heavily. The two are pretty interchangeable though in terms of what they do. So we're going to start with tree diagrams. We're going to get an understanding of them, and then we're going to have a look at lattice diagrams afterwards. So tree diagrams are used when we have multiple events or sequent events. So you might remember from 1A that we had events where we might have tossed a coin. So the possible outcomes were heads or tails. Okay, you can see here this diagram shows tossing two coins. So on the first toss, the options were heads or tails. And on the second toss, the options were again heads or tails for both. And the idea of these tree diagrams is they give us the outcomes. So we could have got a head, 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 tail, tail, head, tail, tail. Okay, that might seem a little like you can do that in your head for that one, but for ones like this, tree diagrams become very, very helpful in sorting out what probability is what. We also can use tree diagrams to calculate the probability of a sequence happening. For example, what is the probability of flipping a head, tail, then tail? That is 1 in 8. Okay, or what is the probability of flipping two heads? 1, 2, 3, 3 out of 8. Okay, so they are very useful once you get your head around them. So as I said, we've got them for multiple events. Now each column, so going down, each column represents one event. So this is the first coin. Okay, and then the second coin goes off of that. So it's almost like, well, if we flipped a head first, we could then flip a head or a tail. If we flipped a tail first, we could then flip a head or a tail. Okay, so it outlines the possible outcome, and you kind of think about it like you're traveling from that corner there along one of these paths, and you're seeing where you end up. Okay, so I just said each column represents an event, and those events might be the same. So example, if we toss a coin, we've got heads and tails, and we want to toss it 4 times. So this is the first toss. 1, 2, 3, 4. That's the second toss. Third toss, and fourth toss. This is one of those units that the neater you are, the easier it's going to be, but just be really careful that those columns line up. Okay, if they don't line up quite that neatly, you're going to have some issues. Okay, when we eventually get through, we're going to go through and we're going to have a look at all the options. So we could toss head, 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 and we're going to make a list. Head, 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 tail, and you're going to work your way through it. And when we're done, we're going to have 2, 4, 6, 8, 10, 12, 14, 16 possible options. Okay, so that's an example where they're all the same. They're tossing a coin every time, but they can be different. So for the example here, trying to decide on shoes, pants, top combo. So out of the shoes, they might have, I don't know, thongs, sand shoes. I can't even think of another type of shoes. High heels. Okay, they might be the options for shoes. And then they might have different types of pants. Just go long or short. And then they might have tops, so red, blue, or yellow. Okay, I'm being lazy. Let's pretend they're all there. Okay, so when we come out of this, we could have a combo of thongs with long pants and a red top. Okay, we could also have thongs with short pants and, long pants and a blue top. Okay, and you would list all of those options. So 18 options. Okay, so they can be used for different events. Each event is a column. The events can be the same, but they do not need to be. So let's go through an example from start to finish. This is question 2 from 11C. So when you do your exercises, feel free to skip this, or you can do it if you want. I won't judge. So what it asks us to do is show all the possible outcomes on a tree diagram, and also to calculate the probability that we get tails and red. So sorry, this is a coin being tossed and a disc that is red on one side and white on the other. So a disc as in like a coin with two sides. So we're going to show the possible outcomes on a tree diagram. So tossing the coin is our first event, and we have two options. We can get heads or tails, okay, or H and T, doesn't matter. And the second event is that we are flipping a disc, and the disc can be red or white Okay, so those are all our events listed on a tree diagram. Now we've just got to figure out what the outcomes could be. So we could have flipped a head and then a red, head and then white, tails and red, tails and white. Okay, now if all of these have the same chance of occurring, you've got 4 options. Therefore, the chance of each of them happening is 1 in 4. But that's our tree diagram there. We've done A. So calculate the probability that the coin lands on tails and the disc lands on red. We're looking at a 1 in 4 chance. Now, that's all well and good when there's an even chance of each outcome, but that is not always the case. So with this example from 11H, Christos has 3 subjects, and his chance of passing maths is 75%, passing science is 60%, and passing English is 50%, sorry. So what we need to do is represent it on a tree diagram, and then we need to calculate the percentages of chances of him passing those subjects. So we're going to start with this tree diagram. Now, this is where it gets a little bit tricky with determining the events. So the events are actually maths. So he passes maths or he doesn't pass maths. Science, where he passes science or he doesn't pass science. And English. That doesn't say English. Where he passes English or doesn't pass. Oh. Sorry. I'm not a fan of tree diagrams. Too hard to draw. Okay, so those are all our outcomes, but they're weighted. So if the chance of him passing maths is 75%, 0.75, then the chance of him not passing maths is 0.25. Okay, because he can either pass it or he doesn't. There's no other options. Now, same with science. Science, he's got a 60% chance of passing, which means he has a 40% chance of failing. So I'm just filling these in. English, he's got 50% chance either way. Please, for the marker's sake of whatever test or exam you do these neatly. So we can have he passes maths, he passes science, he passes English. He passes maths, he passes science, he fails English. He passes maths, he fails science. I'm lost. He passes English. Passes maths, fails science, fails English. They're all the maths ones. And then he fails maths, passes science, passes English, fails maths, passes science, fails English. So you can start to see here where these tree diagrams really come in handy for getting all your options down. Now there's 1, 2, 3, 4, 5, 6, 7, 8 possible options. So I would forgive you for thinking that it's a 1 in 8 chance of any of those happening, but because they've got these weighted chances, it doesn't actually work like that. So to find the chance of passing maths, science and English, we actually need to multiply all the probabilities together. So it's going to be 0.75 times 0.6 times 0.5. Okay, chance of passing maths, chance of passing science, chance of passing English. And that's a 0.225 chance of that happening. Okay, so we're going to multiply it. Now, if this was in a test, I would do all of them. So figure out all 8 probabilities. And I would make sure that when I add up all those probabilities, that they equal 1. Okay, and if they don't equal 1, you've done something wrong and you can go back and you can find it. Okay, I'm going to do the lazy way because that's who I am as a person. And I'm only going to work out the ones I have to. So what are the probability that he passes all 3 subjects? 22.5%. Okay, from this one here. And the second question, he passes at least maths and English. So in this one here, he passes maths and English. Here he passes maths and English, and that's it. Okay, so I also need to figure out the probability of this. So 0.75 because he passed maths. Now he failed science, and there was a 0.4% chance of that happening, and passed English. Okay, now what I'm going to do is I'm going to add them together. So 0.225 plus 0.15. We've got a 37.5% chance of passing maths and English. Okay, and the third one there, what is the chances that he passes at least one subject? Okay, so all of these he passes maths. That one he passes science and English. That he passes science. So it's pretty much all of them but the last one. Again, if you're a diligent student, you add them all up. I'm going to do it the lazy way. I'm going to find out what this is and just take it off 1. So I'm going to go probability of failing maths times the probability of failing science times the probability of failing English is 0.05. So if I go 1 minus 0.05, I've got a 95% chance of passing at least one subject. Okay. It's okay to practice them like this, but make sure you do at least 1 or 2 where you add all of these up and get 1, because it's a really good check, and it's what I would strongly encourage you to do with your assignments and your tests. Okay, just to make sure that you're getting them correct. All right, so 2 very different kind of situations there. These ones were even probabilities, these ones were weighted. Okay. So tree diagrams are really, really good for that kind of thing. The only thing that they kind of let you down with is they can be really messy. And if you've got 4 or 5 outcomes for each event and 4 or 5 events, they can take over an entire page. So we're going to look at another couple of methods that are a bit neater. But that said, you will be asked specifically to use a method. For example, use a tree diagram to do this. So make sure we can do this one as well. All right. So to explain lattice diagrams and why they are better, we're first going to try this example with a tree diagram. 2 dice are rolled and the sum of the faces is noted. For example, if you roll a 1 and a 2, 1 plus 2 is 3. Okay, we're adding them up. But if we wanted to roll a dice, the first event we could get 1, 2, 3, 4, 5, 6. That's what we could roll. I'm already hating this. Okay, and then we could roll for each one of these 1, 2, 3, 4, 5, 6. And for this one, 1, 2, 3, 4, 5, 6. Okay, so there are times, I'm not even going to finish that. There are times when tree diagrams can be an absolute pill and we need to use another option. We don't have to, but we're going to. So a lattice diagram lets you use 2 activities or 2 events. So in this case, 2 dice are rolled. 1 dice being rolled is 1 event, the other dice being rolled is another event. Okay? For something like this with maths, English and science, that's 3 events, so you wouldn't be able to use a lattice diagram. But all a lattice diagram is 1 event down the bottom, so dice 1, and 1 event up the side, so dice 2. So we could roll a 1, 2, 3, 4, 5 or 6, and 1, 2, 3, 4, 5 or 6. Now you can do this 2 ways. You can just list what would happen, so you'd roll a 1 and a 1, a 1 and a 2, 1, 3, 1, I'm getting worse at this, 1, 5, 1, 6. Okay, or if you know what the question's asking, like this one, the sum of the faces, you go, if I roll a 1 and a 1, I'm going to get 2. A 1 and a 2 would give me 3, 1 and a 3 would give me 4. Okay, and you can fill this in. What am I doing? 1 and a 2, yes. Okay, and work our way through. So when you fill it in and you're finished, it's going to look like that. Okay, so it's a lot neater, and my apologies, I don't know what's going on with my stylus, but writing is more difficult than it used to be. That will actually lay it out very nicely and easy to read. So I've got another example here. If we're flipping a coin, our possible outcomes are heads and tails, and we're rolling a dice, that will also give us all the options, and that's what we're trying to find, the options. So there are 12 possible outcomes, okay, and the outcomes are tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5. Okay, so they're all options. And then from that, you can do what is the possibility of rolling a prime number and a tail 3 out of 12. Okay, so they're a bit neater way of writing it. They're really good when you have 2 events, otherwise you can't use them. All right, so that's it, tree diagrams and lattice diagrams. Okay, all right.